Hi everybody, it's Mr. McGowan here. This lecture is on translation, and we're doing a bit of a flip lesson today. We're going to be starting with the diagram at the very end of the note, the 7.1 to 7.3 protein synthesis note, and then we'll talk about the three parts of translation afterwards, the written part. So we're going to go to central dogma. We need to talk about that. And I've got a sheet of plastic over top so I can draw right on it, and we'll see what we can do. So remember, with the central dogma, we have DNA. An RNA polymerase joins on. The RNA polymerase joins on at the promoter, and it copies the one gene into messenger RNA using just RNA nucleotides. The messenger RNA has three things done to it before it can leave the nucleus. It has a 5' cap and a poly A tail added on. The introns are cut out and the exons are spliced together by spliceosomes. It leaves through a nuclear pore and goes into the cytoplasm. In the cytoplasm, the messenger RNA will join up with ribosomes. We haven't really discussed them very much. I've brought some very expensive models in to demonstrate what a ribosome looks like. There is a small subunit and a large subunit. And what actually happens is, during the first part of translation, it's called initiation. So, this belt is going to represent a piece of messenger RNA. The messenger RNA lines up on the small ribosomal subunit so that the AUG codon on the messenger RNA lines up with the P site. So the P site is right here. We'll put a big P right there. And tRNA. So the tRNA with methionine added on it, that's the amino acid, that met tRNA comes in and it joins on at that P site. Always met tRNA, because that's the beginning codon. Then the large subunit sandwiches on like that, and there we have our initiation at the A site. So the A site is right here. That's site A. At the A site, this codon right here, this three-letter nucleotide codon, gets read by activating enzymes. That's what this is supposed to represent. An activating enzyme goes out into the cytoplasm. We have our tRNA with the appropriate amino acid. It gets collected, and whatever this codon says, that amino acid gets brought to it by the tRNA. At the next step of elongation, this amino acid will join on to this amino acid. It's a growing chain. It gets joined together by a peptide bond. That's why it's called a polypeptide. And it will actually move along the messenger RNA like this. So the actual ribosome will move along. And we'll learn later that you can actually have many ribosomes on the same messenger RNA at the same time, and that's called a polysome. So let's put this down. Maybe I'll have it for supper later on. And we'll move over here. So the three steps for translation, we have initiation, elongation, and termination. So again, describing it, small subunit, large subunit, looks kind of like a pair there. There's our met tRNA. So met tRNA joins on at site P. Beside site P is actually site A. So met-tRNA joins on at site P, the large subunit sandwiches it all together, and that's initiation. Elongation, we have our site A, site P, and this is actually called site E. The amino acid that is at site A joins on with a peptide bond with the amino acid at site P, and you'll see that we have an elongating chain of amino acids. Once that happens, the whole ribosome moves 3 nucleotides, 1 codon. So the ribosome is moving 3 steps, 3 nucleotides. That leaves site A open again. The tRNA that was in site P gets ejected. That's why it says E. Along comes a new tRNA with whatever this codon is. The tRNA will have a matching anticodon, and it will carry the appropriate amino acid. So that will continue on many, many hundreds of times, maybe even 1,000 times, and we end up with our polypeptide. Okay, many amino acids join together. Eventually, the stop codon will be reached. So right here, this is the signal, the stop signal. Remember, there are 3 nonsense codons which signal for stop. When the stop signal is reached, terminating factor comes in, it moves into site A, it gives a signal for everything to break up, and we have our polypeptide, we have our large subunit, small subunit, tRNA. We have initiation, so tRNA, the met-tRNA, joins on to the small ribosomal subunit. Let me just reach over and get my small ribosomal subunit. There we go. And it joins on to site P. The mRNA is loaded on. So my mRNA, there we go. mRNA gets loaded on. Beautiful. With the AUG in front of the met-tRNA. Large ribosomal subunit joins on, and there we go. We have our sandwich ready to go. After the initiation complex is formed, the synthesis of the protein chain elongation proceeds as follows. So elongation, process of repositioning the ribosome and exposing the codons and joining the amino acids together. That's called elongation. Ribosome exposes the mRNA at the second binding site, A, next to the AUG. Just remember that the A is next to the P site. And the tRNA with the appropriate anticodon is brought in by activating enzymes and positioned by the enzyme called elongating factor. Didn't mention the elongating factor with the diagram, but there it is. It catalyzes the formation of the peptide bond between the new amino acid at site A and the initial one that was at site P. The initiator tRNA is released from the ribosome. The tRNA on site A slides to site P, which causes the whole ribosome to slide along. So our ribosome moves by 3 nucleotides. A third tRNA with the complementary anticodon attaches at site A, and its amino acid forms a peptide bond, and so on and so on. The tRNA detaches, the ribosome moves along the mRNA, and the process is repeated many, many, many times. Like I said, maybe hundreds of times. Termination. So the peptide chain continues to lengthen until the ribosome reaches a stop codon in the messenger RNA transcript. The messenger RNA transcript and newly formed polypeptide are released from the ribosome. So small subunit comes off, large subunit comes off, and the messenger RNA continues around the cytoplasm. Releasing factors. I'm sorry, when I talked about the diagram, I called them terminating factors. They are actually referred to as releasing factors. The 2 ribosome subunits separate, and the free chain may join the pool of free proteins. There's often numerous actually attached on at the same time. There's many ribosomes actually attached at the same time, so there's a lot of protein that can be made at the same time, and that's referred to as a polysome. There's a couple of good videos, ones that I didn't make, on YouTube. I've got a link here, and also the Amoeba Sisters nice, clear, animated version. So, as always, if you have questions, and you may have one or two, please feel free to ask. This is a complex subject. We are not going to go into any more detail about this, and other than possibly understanding bits and pieces of the central dogma, I'm really not even expecting you to memorize the diagrams.